If you always like to break things and you are currently implementing chaos engineering process within your organization, it means that you're probably looking for a tool. If it is, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the SREs series, where we already had an episode explaining how to get started utilizing SLI and SLO. We also did one episode introducing what is chaos engineering. Today's episode will be focused on introducing a CNCF project named Litmus Chaos. If you enjoy today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We will start with an introduction, reminding the challenges and the value of chaos engineering in Kubernetes. We will, of course, describe the Litmus Chaos platform, and we will jump specifically to the ChaosHub, describing the various experiments available for Kubernetes. We will share a few best practices when you have to create your own chaos experiments. And last, as usual, we'll jump into a tutorial. During the episode related to how to optimize your Kubernetes cluster, we explained that requests and limits is clearly a Kubernetes best practice. But remember, if you don't define the right value on the requests and limits, we can clearly have issues on our cluster. First of all, we could impact our users. The response time could be unacceptable due to the limits behavior. We could also have unstable behavior because a lot of failures will be introduced. And last, if the requests are too high, well, we allocate resources in our cluster and we aren't able to utilize them. So at the end, we are paying for our nodes and we are not utilizing them properly.
Oh, okay.
Kubernetes could be considered to be quite complex to operate. There are a lot of configurations and settings that at the end of the day could basically, if you don't define it well, impact our users. And for that, don't worry, there is a good news. If you utilize chaos engineering, then you would have the ability to validate your configurations and measure the impact of your settings. So you could basically list all the Kubernetes events that are problematic for our users, like evictions or OMKill, and then you could simulate that through experiments. To remind quickly, Kubernetes rely on nodes, and nodes at the end of the day is physical or virtual servers. Once a node is saturated in terms of CPU, memory, disk, whatever you want, Kubernetes will try to manage the infrastructure issue by starting an eviction process. So first, it will detect pods that are in a low priority. Then it will kill one of those pods and reschedule them elsewhere on another node. By moving that pod, basically there's a big chance that we have released some CPU, we have released some memory on the node, and we are probably have resolved our node pressure situation. Like explained in the episode introducing chaos engineering, there are various chaos engineering tools available on the market. From all the tools that we saw, there are few of them that are designed for Kubernetes. Today, this episode will be focusing on one of the chaos engineering platform, Litmus Chaos. Litmus Chaos has been specially designed for Kubernetes. Litmus is a very promising CNCF project that has of now more than 3 years of experience. Version 1 was providing the core concept and component of Litmus and didn't have any web UI. Since the version 2X, Litmus provides now a web UI named the Chaos Center, helping us to configure, schedule, and validate our experiments. So let's have a look at the latest version of Litmus, the Litmus Chaos version 2.7. Litmus Chaos comes with an operator and several CRDs that will help us to design, deploy our chaos experiments. The web UI, the Chaos Center, will help us to configure our workflow, our experiments, our monitoring, and more. And last, there's another component called the agent. The agent is very important. The Chaos Center needs to be connected to at least one agent. The agent will be deployed either in the same cluster as Litmus Chaos or in the remote cluster where you want to apply chaos experiments. And the agent is designed to trigger workflow and run your experiment. The Litmus Chaos architecture is based on a control plane and an execution plane. The control plane is composed of all the components required to run Chaos Center, the web UI. So database, web UI, and so on. Then you have the execution plane. There are several components required to be able to execute our experiments in our environment. So first, we have the agent. The agent stack is required to trigger experiments against our environment. The agent stack is composed of a controller workflow that triggers workflow specified in the Chaos Center. The subscriber. So the subscriber is technically the component in charge of receiving the instructions from Litmus Chaos Center. And last, the Chaos Exporter. The Chaos Exporter produces metrics from our experiments in a Prometheus format. So at the end of the day, the Chaos Exporter is a Prometheus exporter. The execution stack is in charge of running the design workflow. It will trigger the chaos workflow through Argo workflow. During the execution of our workflow, we would have several components that will be created through that workflow. First, the experiment, the engine, the runner, and last, the results. In fact, Litmus Chaos comes with a couple of CRDs. So the chaos workflow, which is an Argo workflow that describes the steps of the workflow. The chaos experiments that defines the execution of one of the steps of the workflow. So basically our failure, the errors that we try to inject in our environment. Then we have the chaos engine that holds all the information on how to execute that experiment against our environment. We have the chaos runner, created by, in fact, the operator, that will execute, at the end of the day, our experiments. And last, there is the chaos result that will hold the results of our experiments. At the end of the day, you will probably configure most of your chaos workflow on the Chaos Center. From the web UI, the configuration will be very easy to define your workflow, the various experiments within that workflow, and you will be able to launch it automatically from the web UI. What is amazing is that Chaos Workflow relies on Argo Workflow. It means that we have the freedom to design a custom flow, triggering a load test in parallel experiments. I think supporting Argo Workflow is a great idea, even if Argo Workflow could be sometimes very frustrating, to design and to configure. But once the painful period is over, it's just incredible. You can achieve tons of things through Argo Workflow. The other part of Chaos experiments is the ability to launch probes that will help us to measure our steady state and abort experiments in case of something is going wrong. Litmus brings all the features that we expect out of a chaos engineering platform, like Cyan Mandel mentioned in our previous episode on chaos engineering. Litmus has added more integration with ticketing system, CI/CD, and it will provide also one cool thing, which is application experience. Litmus Chaos offers a ChaosHub. ChaosHub is basically hosted on litmuschaos.io. You can go, here is the website, and it has more than 50 plus predefined experiments for Kubernetes, for Cassandra, with Amazon, Kafka, CoreDNS, GCP, Azure, and more. So let's have a look at a couple of predefined experiments for Kubernetes, because here we're fishing experiments for Kubernetes. So there are experiments that are dedicated for pods. So we can kill containers, we can fill a disk, we could autoscale a pod to test the autoscaling policy. There is all the experiments that will generate CPU stress, like the pod CPU hog, or you can do pod CPU hog exec, where you can execute specific tasks. You have pod delete, anything related to the network, so pod DNS error, pod DNS spoof, disks, pod IO stress, and memory as well, so pod memory hog, and pod memory network corruptions, duplication, latency, network loss, and so on. And then, of course, on the layer above the pod, you have the node. So there are specific experiments on the node, like killing the Docker services, killing kubelet, and generating stress on the CPU, node drain to remove one drain of the cluster, node IO stress, node memory, node restart, and node taint. For most of the experiments, you will specify the target, either the exact and specific list of the pod name and the node name, or you can use label selector and precise a percentage of pods or nodes that you would like to impact during your experiments. With the generic Kubernetes experiments, you will have all the right assets to start testing and validating your Kubernetes settings. For example, if you want to test the impact of the evictions, like described in the introduction, we could utilize the following workflow. First, we probably have lots of nodes in our cluster, so we could basically reduce the number of nodes by node drain one or more nodes in our cluster. Then, because we want to simulate a node pressure situation, we probably want to stress our nodes. So we're going to do probably some node CPU hog or node memory hog and more. To validate our experiments, we want to measure the impact of evictions to our users. So we're probably going to trigger a load test having a constant load. The load test won't be there to apply stress, because we want to have a constant load to just measure the impact of evictions on the response times or on the failure rates of our users. Most of the experiments available in the ChaosHub, and especially the one for Kubernetes, requires to specify your target. So in case of Kubernetes, the pod name or the node name. For maintenance perspective, it makes sense to avoid as much as possible to specify static pod name or node name in our experiment. Litmus Chaos can be installed in various ways, directly in the cluster that you are planning to test, or in a dedicated cluster for testing tools. If you choose to install Litmus in the same cluster as your application, then it will be very important to organize your cluster in a way to have dedicated nodes for your applications and dedicated nodes for your testing tools, like Litmus. For that, I would recommend to label your nodes and only apply experiments on the node having the right labels. So at the end of the day, we can be very creative by having labels for testing tools, Litmus, K6, load testing tools, ticketing systems, whatever, CI/CD process, whatever. Labels, nodes, 1, 2, 3, clap. So at the end of the day, we could be very creative by labeling nodes that will host dedicated pods for our testing tools, like Litmus, like load testing tools like K6, and others. We can have nodes dedicated for our observability, so for Prometheus, for example, and other applications. To be able to validate our experiments, we don't want to lose observability and impact experiments. So that's why we want to have dedicated nodes for the observability and make sure that the experiments won't run on those nodes. On the experiments for the pods, it's usually been configured by specifying the target pods or by specifying the application namespace or the application label. Currently, it's app and then something. Make sure that the app label is also there in your desired workload. If you're using a separate cluster, make sure to label properly your node or deployment to be sure to only impact your target application and not your neighbors. In this tutorial, we will try to configure the experiments that will help us to test the impact of evictions on our application. To be able to achieve this, we will need to create a Kubernetes cluster, of course. We will need to label our nodes and separate the observability tools on specific nodes, the testing tools on specific nodes, and then nodes that will host our application. We will deploy Nginx ingress controller that will help us to expose the application, the Chaos Center, Grafana, and more. We will deploy the Prometheus operator. We will deploy Litmus Chaos, configure the ingress controller to expose the Chaos Center, deploy a service monitor to collect the metrics exposed by the Chaos exporter. Then we will configure several experiments to test our specific event, the evictions, or at least design some workflow.
Like every tutorials that we deliver at Is It Observable, there is always a GitHub repo related to this episode. So here is the episode related to what is Litmus Chaos and what is chaos engineering. And you will find all the various steps to run these tutorials at your own pace, with your own environment. So you need a Kubernetes cluster. So I picked Google Cloud like usual. But make sure to clone this repo, and like explained, the first thing that you would need to do, make sure to label your nodes. So to do that, you kubectl get nodes, so you have your list of your nodes in your cluster, and then for each node you will have to do equal, and then we had observability in one side and worker on the other side. So in my case, I have 4 nodes. So I have 2 of them for observability toolings and testing in general, and 2 others for the application that will be the Litmus shop. So when you're going to deploy the various toolings like Nginx, the Prometheus, and the others, make sure to deploy them on the right nodes with the right node selector. So I already have installed most of the things, so make sure that you have in your cluster the namespace ingress Nginx for Nginx, because Nginx will be used to route our traffic. I already have deployed Prometheus in the default namespace on the nodes that are labeled observability. So this is what you will have with the Prometheus stack. Here, this is the official websites for Litmus Chaos, and you have the getting started guide, which is here, that will walk through the various way of deploying Litmus in your environment. In our case, we will use Helm. So first thing that we need is obviously we're going to create a Litmus namespace. Once we have a Litmus namespace, then I will deploy the new Helm charts. So install Litmus. So the Litmus Chaos, there's a new repo, which I already have, so I can add it. But in the README file, I have suggested a command to deploy Litmus utilizing the right label selector. So please utilize this one. So I'm gonna show it, and I'm gonna deploy with all the variables that I need. All right. So now you can see here I have forced the usage of an ingress host name and the front end and everything. And everything is referring to observability. This is the node type that will be used for this one. So let's have a look first on what we get out of this deployment. So you can see that we have the Mongo, the Litmus server, the front-end server, and the authentication server that are currently starting. Make sure that normally with the right Helm variable, the ingress will be deployed and the services will be properly configured. So make sure that the services in your Litmus Helm space are all in cluster IP. The other thing is in the namespace Litmus, in our case, there is an ingress. So make sure that Litmus ingress is there. So we have already deployed with the right variable, but also there are 3 annotations to add. Make sure to add those 3 annotations. We need the Kubernetes nginx ingress class, and we need the 2 other annotations for nginx, the one with the regular expressions, and then you will be good to go. So once you have applied these changes on the ingress, if of course your service is in the cluster IP, then you will be able to reach out to your Litmus Chaos environment. Here is my Litmus host name, so let me grab this one and try to open it in the browser. So normally, if everything goes well, you will get to the main page, the welcome page of the Chaos Center. And something which is important, once you're going to enter in the Litmus Chaos Center for the first time, it will deploy also by default the agent in the same cluster. And let's open. So now it requests to change the password, of course. All right, so here it is. As you can see, we arrive in the Chaos Center screen. The Chaos Center screen will show you that there's one project, there is one agent. So we can check on the agent side. So here it's pending. So it's currently in the deployment phase. I will show you in a few seconds what you're going to get in the cluster. You can see that we have an access to the ChaosHub. So we have access to the default ChaosHub available with the 50 experiments. And then we have observability layers and so on. Once we have started, as you can see, we have extra pods related to our agents. So we have the Chaos exporter, the operator, the event tracker, the subscriber, and the workflow. So those are basically the execution plane. So for the execution plane, we did not precise any nodes selector. So Litmus is basically deploying them without any node selector. So that's why it's important to make sure, if you want to basically isolate those components on the other nodes, to also have those there. So let's see the new deployments that Litmus has added. Here it is. You can see that we have the Chaos exporter, Chaos operator, the event tracker, the subscriber, and the workflow. So for those, what I will do, I will edit those to make sure that they are running in the node type observability. So here in this in the deployment specifications, I'm going to add, after the container sections, a node selector part. Here it is. So now node selector needs to be in this level, and then I'm going to add. So here I did this one for the Chaos exporter. Now I can do the same thing for the Chaos operator. So basically you have all of those to update. So the Chaos exporter, the operator, the subscriber, the event tracker, and the workflow controller. So those are the 3 of those needs to be updated. All right. So second, I did for the operator. Now I'm doing the same thing for the event tracker. Okay, and last, the subscriber. And the workflow controller. All right, to add the observability layer, we need, obviously, we're going to add the Prometheus layer. So we need to get the service name of Prometheus running in our case, it's in the default namespace. So I'm just going to get SVC. So now I can see all the various components running in the default namespace. And the one that we're looking for is the one that is Prometheus Cube, this one. This is the one that I would like to connect to. So I'm going to grab this one. So that's the right service name. So if here I can basically click on Observability, add a new data source, and here we're going to call it Prometheus. So once we have our services, we can copy paste it. So Prometheus Cube Prometheus, and then it's on the default namespace. So default, then SVC, then cluster.local. So that's the entire URL for Kubernetes in our case. It's a Prometheus. I'm going to check. So now check. There is no authentication in my case. And then scrap interval 50 seconds, query timeout, and so on. So now it's been added. So I can go back to the observability layer and check the monitoring. So let's go to monitoring dashboard. I can create a new one. I can create workflow statistics to collect. For this, we would need to apply a new pod or service monitor to let Prometheus grab those new metrics. So this is not populated, so we need to apply the right service monitor. I'm going to do it in a few seconds, by the way. So if you do a new dashboard, so we can say there are a couple of templates, so custom dashboards. You can upload your own ones. So I'm going to first look at the pod metrics. So here we got node metrics. Our data source is Prometheus, and then we can select where we want to get the application namespace. In our case, it's not deployed yet, so we will configure that in a few seconds. So then if I do next, I can see again, I want to see the chaos, the CPU utilization, the memory, the disk usage, the network, and so on. So now I click on next. So we have a Prometheus folder, and within this folder, we have a pod monitor file. So if we do a cat on this pod monitor file, we can see that at the end, it's not a pod monitor, it's a service monitor that will grab the metrics from the Chaos exporter. So let's apply this file. Now that we have everything, one thing which is important, we're going to use a K6 for in our workflows. So we need to make sure that the Prometheus is well configured. So the Prometheus operator comes with new CRDs, and there is a one called the Prometheus object, which has all the configuration related to Prometheus. So let's get the name of this Prometheus object, which is here, and we can basically edit this one. And this K6 plugin requires to enable some features, and this is the things that you need to make sure to enable. It's the remote write receiver, because K6 is going to write statistics and metrics collected through the load test in Prometheus utilizing this feature. So make sure to have this enabled as well. So now that we have everything, we could basically apply our applications. So we have two ingress that we need to expose, one for Grafana and one for the online boutique. So first, so we have here the Grafana repo. In this Grafana repo, there's the ingress file that you will need to apply. So now we have the Grafana ingress configured. Now let's create a new namespace with the hipster shop. So let me apply this So let me check the ingress status directly from Google Cloud Console, where I'm seeing here all the ingress running. I can see that we have the Grafana one and the online boutique. So here we have our pod metrics. And now that we have applied this new namespace, we should have the hipster shop here. But let me go back and reconfigure. The namespace will be the hipster shop. Here it is. And we will also look at the default one and the ingress one. That was the main three things that we are looking for. So here we have all the pods. So we can basically maybe focus on the pods related to hipster shop. And now we can see the CPU usage and the memory usage on all of those pods. And those you can see are coming directly. Now that we have configured the observability layer and with the service monitor, I've executed a few test runs. You can see that the results are populated. So you have a dashboard on what happens on your various experiments that you have executed. But moreover, let's have a look at a few things that are important. Especially what you're going to do on your day-to-day basis is go to Litmus workflow. And this is where you're going to do your workflow. So if I do a schedule workflow, I need to select the agent. So in my case, it's the agent running on my same cluster, but you have a remote cluster, you will see it. And then here you have several options. You can either use a template that you have defined, use existing workflows, or use the ChaosHub. And this is the one I'm going to use. Later on, I'm going to show you one YAML file that I have created with a more complex workflow utilizing Argo workflow. So here we can give a name. So let's just give that name, that will be fine. And then what is great is here at the first thing that will happen in any situation is, of course, install your Chaos experiments. And based on the experiments, there are a few things that Litmus needs is obviously some the right service account to interact with the cluster or the pod. So that's the thing. Now we're going to add a new experiment. And by doing add new experiments here, it will list basically all the experiments available currently in the ChaosHub. So if I want to trigger specific experiments related to Kubernetes, it's usually generic. So let's say I'm going to take node drain, I can do done, and that you can see the Argo workflow being designed as we create it. So here we can see that we have only node drain. So let's add any other experiments. Let's say I want to do node CPU hog. So node CPU hog is here. I do done. As you can see, it's at the moment it's a sequential workflow, but you can still edit the sequence. By editing the sequence, I can take one of those steps and drag and drop it to make it parallel. So it's like I take this one, I put it here. So then it means that in parallel, we will have two experiments, node drain and CPU hog. The last step related to our experiments, obviously, is you see the deploying, but I'll show you in a few seconds. What is important is once you have add new experiments in your workflow, you can adjust it. So you give a name, experiments, and then this is where you're going to put the target. So I'm not going to put any annotations because I need to modify all my workload and I'm not interested. I'm not going to put the node selector because it's quite static as of now, the node selector. But here you can see here I can create a new probe if I want. So I can say there are several type of probes available in Litmus. There is the HTTP, the command line, the Kubernetes, and the prom. So prom will be sending a prom QL, Kubernetes to check if one of those pods or service is up and running, the conditions related to that component, command line, and HTTP. Obviously, I can reach out to specific things. So probes will be very important because that will be a way of measuring the steady state of your app or aborting your experiments if it's failing. So then you hear this is the experiment itself. So here I can say the duration of experiments and the target node. And like I said, this is going to be exactly the node ID, the node name, which I don't want to. There's another key for this experiment called the node label. So I will use it in my case. I'm not running this one, but I'm going through the various steps that you need. One important thing is when it comes to chaos experiments, there is a documentation. So I will briefly jump to it. But basically here you will have to configure each of your experiments one by one. Then if you go to advanced here, there's a few things that we want to, you can put tolerance, basically to put some taints and tolerance if you want. But here, what is important is that what do we want to do at the end of our experiments? You want to clean up the workflow pods because you don't want to have them running forever. So this will determine the conditions. So if I do on success, it means if they are failing, I can still see the problems and basically get the logs and basically adjust it. Once I've done this, then I can allocate points. So if there are experiments that are more critical to your evaluation, you can attribute less or more points on your flow. And once you have done this, you can either schedule to run it now or recurrent schedule. So you can say every hour or every day and a certain time and so on and so forth. So here I go to the ChaosHub here. Every experiment has its, let's say, CPU hog, for example, pod CPU hog. Once I have the few information about the experiment itself, but the more important, what I would recommend for every experiment that you need, look at the documentation section, because here you will see the couple of requirements and all the parameters to tune up your experiments. Remember, I said that you will have the target containers or target pods, but you can also use labels as well. That works fine. Depending, of course, of the experiments, there are more or less parameters available. So that's for the predefined and packaged workflow that you can build directly from the Chaos Center. One thing that I wanted to do, like I mentioned, I want to combine with load testing. So the great thing is because it's an Argo workflow, you have the ability to do so. And in the repo that I just shared, there is a specific workflow that I've designed. So what the Litmus is doing when you design it from the UI perspective, it basically creates that YAML file that I'm showing you. It builds the Argo workflow configuration file. So you can start from the Litmus to create your own workflow that you need and then adjust it by defining new steps. So here I'm using the steps of Argo, but you can use also DAG if you want, depending on the complexity of your flow. But here you can see I'm installing first the experiments, and then in parallel, I will run those various tasks. So first I will do a node drain. In parallel, I will do a CPU hog, and in parallel, I will do a memory hog. And last, I will run in same time in parallel K6 load. And that is great because it allows me to trigger load test as also one of the task part of the experiment. So I can trigger everything. And last, we do the revert. So here, this is the K6 stuff here, where I basically just ask to trigger a new container that has the K6 load test for Hipster Shop. And I just need to have a parameter to reach out to the right URL of the Hipster Shop. So very simple. So that if I trigger it right now, I can do it right away. I will schedule a workflow, and is here in my case, it's going to use the YAML file. So I can drop that YAML file that is in the repo here, and I'm going to trigger it. And by doing this, I can view the YAML. So you see the YAML will be the same one, but I don't want to do this. I can directly go to the workflow, and by clicking here, I can see the state of the various steps of my Argo workflow, either by a graph view or by a table view. So here we are at the first step, which is installing the experiments. What could be interesting is to look at what's going on the Litmus Chaos namespace. So if I do a kubectl get pods in the Litmus namespace, or I can do, or not pods, in fact, workflow, because it's a workflow. I will be able to see that I have a couple of workflow that has been succeeded, and now we have one that is running 38 seconds ago. And as you can see, now that we have the the flow deployed, now it's going to deploy as the next step, first the experiment, then the engine. So if I do here, instead of, I do chaos experiment, you can see that now we have 3 experiments that is there. So the CPU hog, the node drain, and the memory hog, the one that we're looking for. And if I do the same thing now with the chaos engine that will bring the chaos runner, I can see that I have also there. And what could be interesting is if I do a kubectl pods, I should see here the various pods related to my experiments. So I can see that we have the node memory hog, we have the node drain with the node runner. So here runner is the actual execution, the node drain, and we have the CPU hog with the CPU runner.
That's it for today's episode related to Litmus Chaos. As you can see, Litmus Chaos provides a lot of great features, and I really like the fact that there are a lot of predefined experiments. The other great thing, I think, is related to the fact that you can run your own Argo workflow. So you can basically have a lot of options, and if you're creative, you can design a lot of complex chaos workflow utilizing, at the end of the day, the Argo workflows. If you enjoyed today's content, don't forget to like and subscribe to the channel. Thank you for watching, and see you soon for another episode. Bye.